So today we're going to talk about something pretty huge. We're looking at a protocol that could basically build a whole new internet, but one that's designed from the ground up just for AI. It's called the Distributed Model Context Protocol, or D-MCP for short, and it's trying to tackle one of the absolute biggest headaches in the world of artificial intelligence right now.
And that brings us to the big question, right? The one that's driving this entire conversation. How do we actually build an internet that's native to AI? An internet where all this incredible knowledge isn't just stuck in little isolated boxes, but can be shared, like instantly and super efficiently, no matter where you are in the world.
Okay, so before we can get to that future, we've got to look at where we are right now. We need to understand the foundation we're building on. And that foundation, it's a protocol that's already, for all intents and purposes, the standard in the AI world. It's called the Model Context Protocol, or just MCP.
The easiest way to think about MCP is like a universal translator, or maybe a bridge. So on one side, you've got your AI apps, your agents, whatever you're running. And on the other side, all the external tools and data they need to be smart. MCP is what connects them. It creates this standard language so they can talk to each other. This is how an AI can pull in real-time facts or use a specific tool to give you a response that's actually, accurate and useful.
So here's the thing about MCP. It's kind of got this split personality. On one hand, it's awesome. It connects tools to AI, it makes our prompts way smarter. But, and this is a big but, on the other hand, it has a huge architectural flaw. It's built on a really simple client-server model. And what that does is it turns every single setup into its own little isolated island of context. That works okay for one person, maybe a small team, but when you try to scale that up globally, oh man, it just completely falls apart.
And you know what's wild? This whole scaling problem, it's not new. This is a story the internet has already lived through and solved once before. The problems we're seeing with AI infrastructure today, they look almost exactly like the problems the web had way back in the early days.
I mean, think back to the early web, if you can. Remember dial-up? Every single time you wanted to load a picture, your computer had to send a request all the way to one single server somewhere in the world. It was painfully slow, super unreliable. But then, in the late 90s, this idea called a content delivery network, a CDN, popped up, and it literally changed the game. It's the reason we have the fast global web we all take for granted today.
So, what is a CDN really? What does it do? Well, at its core, it's a really smart network that just makes copies. It copies web content, images, videos, all that stuff, and it stores those copies in servers all over the globe, so they're physically closer to you. That's it. That simple idea is what makes everything so fast.
And just to give you a sense of how big this solution became, get this. Today, something like 72% of all global internet traffic runs through a CDN. That is staggering. They're not just some nice-to-have feature, they are a core, fundamental part of the internet. Without CDNs, forget about Netflix, forget about online shopping, none of it would work.
And that right there, that brings us to the big idea. If we manage to scale content across the globe, what if we could do the same thing for intelligence itself? To do that, we need a whole new kind of delivery network, one that isn't built for static pictures, but for dynamic, ever-changing AI context.
Okay, so this is where it all comes together. This is where we take that huge lesson from the history of the web and we apply it to the future of AI. This is the aha moment. This is what makes the whole thing just click.
All right, here it is, the key takeaway. D-MCP is, for all intents and purposes, a CDN for AI. Simple as that. A normal CDN caches stuff like images and JavaScript. D-MCP, it caches AI context. We're talking about embeddings, memories, RAG chunks, all the little building blocks of an AI's brain. A CDN saves bandwidth. D-MCP saves GPU usage and, importantly, money. It is the exact same brilliant idea, just applied to this new, much more complex world of AI data.
Okay, so that sounds great in theory, but how does this CDN for AI actually work in practice? Let's break down the architecture and see what makes it tick.
All right, there are basically three big steps. First, it federates all the tools. Now, what that means is if I have, say, a really fancy tool for reading text out of images, anyone else on the network can use it as if it were running on their own machine. It creates this one giant global toolbox. Second, it organizes all the knowledge into shared channels. You can think of these like topic-specific group chats. All the context for a project lives in one place. It's stored once, and everyone can pull from it. No more duplication. And finally, step 3, it distributes the compute. It's smart. It automatically sends your request to the nearest, or the cheapest, or just the most available GPU, whether that's on your laptop, at the edge, or in the cloud. That alone saves a ton of time and money.
So, okay, that's a lot of technical stuff. But why does it actually matter? What's the so what? Well, the payoff here is just enormous. This isn't just about making AI a little bit smarter. It's about making it radically cheaper and way more accessible for everyone, everywhere. Because you're constantly caching and reusing context, you stop doing the same work over and over again. And what does that mean? It means your GPU costs go way, way down. You use significantly fewer tokens for every single query. It means you can actually run powerful AI on small devices like your phone, because the heavy lifting happens on the network. But maybe the biggest thing? It completely shatters those information silos between different teams and companies. Oh, and as a bonus, it helps you get more life out of the hardware you already own by using it way more efficiently.
Let's make this real. Imagine a use case like scientific discovery. You've got 3 researchers, Leo, Jigar, and Nikesh. They're in completely different labs, maybe even different countries. Leo finishes up some work and uploads a new research paper. Instantly, and I mean literally instantly, Jigar and Nikesh can start querying that paper, asking it questions, building on its findings, all in real time. Why? Because they're all part of the same shared context channel. The knowledge just flows. And you can see how that would just massively speed up the pace of discovery, right?
Or how about another huge one, healthcare? Picture this. A doctor at one hospital uploads some de-identified notes about a patient with a really rare disease. Now, miles away, a totally different doctor is stumped by a patient with similar symptoms. They query the network, and without either doctor even knowing about the other, D-MCP connects the dots. It finds the patterns in that shared context. That could be the key to a faster diagnosis. It's powerful stuff.
So, when you put it all together, you see that D-MCP isn't just like an incremental upgrade. It's way bigger than that. This is a foundational layer for a totally new kind of internet, an AI-native internet, one that's built on a distributed architecture, ready for RAG, and all about sharing context. We're talking about a shift from an internet that just delivers information to one that actively shares and builds intelligence. And that leaves us with a final thought. The real question isn't if something like this is going to happen, it's what incredible things we're going to unlock when it does.